Well, hi, good morning. Thanks so much for joining me in my shop here. It's October 18th. Oh my gosh, October 18th. Now, from time to time when I'm working on these old radios, I run into one that was commonly referred to as a dog. That's a radio that you just can't seem to figure out what's wrong, or you just can't seem to overcome the problem in it. Here's one. The Bradna. I worked on this radio, you might recall if you've been watching a lot of my videos, back in July. It's October now. July, August, September, October. Well, it's not that long ago. 3 months ago. I set it aside because I couldn't overcome what appears to be a problem with the radio's tube sockets. It's an interesting radio. There's not a lot of these around, I'm pretty sure. This is a rather obscure radio, in fact, from an obscure company. The radio is called the Bradna, but the company is called the... I better look at it. Let's put this down. I'm going to slam it. The Breadner Company, Ottawa, here in Ontario, in Canada. I think I did all the work on it, and the last thing was trying to overcome intermittent tube contacts. Well, in the meantime, I have acquired the oh-so-famous Deoxit. So here's an opportunity for me to literally spray this stuff down in the tube sockets, click my heels 3 times, and see if that doesn't fix it. So I think first step here, I'm going to take it out of the cabinet. If I can. I don't remember. Yep. Out it comes. Very good. How did I do this before? I'm going to stick it like this. Crazy as it seems. Nice big sheet of asbestos sitting in there. It does not look to be in very good shape either. And I'm going to deal with that too. Okay. So the antenna appears to be in the lid. So when you flip this up, you're flipping up the antenna. And there's the antenna lead wire. It's a shielded spring shielded wire. That's what this is all about. Some kind of loop antenna up there. Probably if we open this up, and I'm not about to do that, we would find something very typical of a loop antenna. Let's see if I can just prop this up. Let me just stop for a minute and get this propped up a little neater than the way it is now. So the last video I posted, not on this radio, but the video I posted yesterday, at the end of it I talked about bringing this radio in here to work on it, and I mentioned that this is a battery operated radio, and the owner has a battery, I still don't know the word for it, battery replacer, battery power supply. Wait a minute, this is a plug-in radio. It has a switch here to select battery or power, and what I've done is I've disabled the battery side of this completely, so it relies only now on power from the wall. I'd forgotten that, but I remember it now. So what I want to do is plug it in, turn it on, and just see what it does. Pretty sure it was one tube in particular that I just could never get stable. Let me make sure these are all down and in their sockets properly. Also, this radio is full of what I consider to be very delicate 1-volt tubes that are easy to destroy. I don't want to do that, so we'll power it up here. Let's just make sure it's... Oh, I need to be pretty muscular to work that switch. Okay, so it's switched on. Going to run it through the dim bulbs, just the one bulb, but it should come on pretty quick. Almost instant on, the 1 volt. tubes. There it is already. What's the problem? Seems fine. Oh, ow, 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 ow. Hurt my ears. Don't know if I aligned this radio. I'm not sure I got to that point. Well, with the antenna up here on my bench, it's a little unrealistic to expect this to work really well in terms of reception. What about this tube problem? Definitely some funny business in it. Okay, well, the tubes aren't acting up on their own. Or are they? I heard some sharp clicks while I've been tuning the radio back and forth. Like that. A couple more. Okay, I'm going to give it the light tap. See what happens. Something is ringing. That musical sound you're hearing is coming out of the speaker. Just light taps. Looking for anything that's really sensitive. Where's the problem? This tube is microphonic. Chances are that's the output tube, but I'm not sure. Just looking at it. Well, oh, what just happened there? Okay, a little more aggressive. That's aggressive. There's one there. Oh, this guy. Okay, so I'm terribly concerned about destroying all these tubes. There are warnings with these radios never to pull a tube out while it's operating. Let's see if I can find that in here. Important. When set is out of use for periods over a month, remove the battery. No, that's nothing to be concerned about. Do not remove or replace tubes while set is switched on. So as I'm wiggling away here, I could break the heater contact, and that's pretty much the same as pulling the tube out. And I think that's the point where everything else can leave very quickly. So a little nerve-wracking, very nerve-wracking. Okay, so I'm going to pull the tubes out. We're going to spray it with Deoxit. Now, I've stayed away from this stuff for all my life, right up until I bought this specifically for this radio. What is in here? All electronic connections deteriorate, causing reduced performance and eventually total failure. Deoxit rejuvenates, whatever that means, and improves performance and reliability of all, in capitals, all electronic parts and equipment. People swear by this stuff, but we're going to put it to the test here, I think. Turn off equipment. Adjust valve all the way up or down. All the way up or all the way down, I guess. Until it clicks into place. Be careful, I'm going to spray my camera there. Apply a short burst of Deoxit onto the metal surface. Operate the part or device to help break up oxides and contamination. Wait a few seconds. Reapply one shot burst. Wait 2 minutes before turning on equipment. For additional protection, follow up with Deoxit Gold or Deoxit Shield. Note, test for compatibility before use on delicate devices, phones, cameras. Yikes. Spray onto a swab or cloth, then wipe on a metal surface. Do not spray directly onto device. Also available, mini spray, pens, wipes, brush, needle tip, squeeze tubes, and bulk containers. Unlimited uses. All metal electronic connections, audio, video, computers, cables, rechargeable devices, flashlight switches, contacts, phones, plugs, sockets. There you are, sockets. Batteries, headphones. Spray it right in your headphones. Spray it right in your ear, for crying out loud. Toys, cameras, lighting electronics, industrial equipment, and many more. Wow, they just couldn't think of anything more to put in that list. Or they ran out of space on here. Well, very promising. Try Deoxit DNS spray. Quick dry, non-drip, non-flammable. That's something else, I think. Flex tip for those hard to reach areas purchased separately. Cleaner audio. Clearer video. Reliable data. Boy, the marketing department really went to town on this, didn't they? Used worldwide by industry experts. Well, that's not me, that's for sure. 65 plus years. Well, that's also not me. I'm not there yet. Close, but not quite there. Okay, nothing particularly spectacular there. So we're going to do this one, maybe 2 tubes at a time. I've got 2 here that have already acted up, so I'm going to pull them out. Now, should I spray the prongs and then stick them in, or spray it down in? So it says spray a little bit, work it, spray a bunch more. So what you're trying to do there is use the liquid to and this kind of working action to break up whatever is in the thing, the tube socket in this case. And then the second shot is to wash it out, to wash it away. I think I can wash it away here. Let's see. It's a very expensive WD-40. Here we go. Okay, I think that went down inside. Now we'll work the tube. So working a tube like this is how I usually do pin cleaning. I just give it a couple of walk-arounds like this. But of course you can loosen up the tube grips, which can be part of the whole problem you're trying to deal with. Okay, we're going to go in and out a couple times here. Okay, and now we are going to wash it away. Wash it away. Jeepers creepers. Don't know how much of that actually went in versus how much. Okay, I'll pull this out and give it a chance to dry a little bit. Okay, I'll pull out this tube here. Generally speaking, I've had very little trouble with tube sockets in radios. Lucky me. I looked and looked and looked around my house for a little tiny brush I could get in there with, which I really like to do. Couldn't find one. Like a razor, electric razor brush. Tube sockets feel like they're gripping the tube quite nicely. Okay, and now the rinse. Oh boy, it goes everywhere. Definitely flooded it there. It's got to be dripping out the bottom. But it's good for everything. Good for everything. Good for what ails you. If this is like WD-40, when the volatiles come off, it leaves behind an oil of some sort. Okay, we're going to give that a few minutes to dry up. I can see this one's drying up. And then we'll give it a test. Okay, let's see what's been achieved here. Here we go. Quite a hum coming out of this radio. So I think it's oh, she's gone quiet. What exactly is that? It sounds like it's breaking into an oscillation. Okay, wiggle the tube here. I didn't even touch it. Is that the normal operation? Jeepers creepers. Let's put it over here. Okay. Seems better. Oops. So I think one of the questions I had was if some of the problems being exhibited by the radio at this point, is it from bad tube contacts, or is there something more going on in the radio? Oh boy. There seems pretty good. That is the tube of problems. The tube of problems. I seem to remember trying to file these a little bit. That's kind of a humorous undertaking. It does look like there's some corrosion on there. Why don't we get a really close look at these pins? That's gonna maybe, oh, there's still a lot of fluid here. Hasn't gone away. It's definitely an oil in that. For sure. Okay, yeah, I'm gonna get my microscope set up. We'll take a close look. Yeah, instead of a microscope, which is clumsy, I'm going to use the cinema camera here, which gives a really good close-up. Let's take a look at what we can see here. Whoa! pretty scratched up. That's probably from me trying to file them. They're a little bent. A little bit of a bend in them. So this one right here. Would that bend cause a problem? I can't imagine it. You got bent from being pulled out awkwardly. That's what I would guess. Well, certainly doesn't seem to be any kind of serious buildup of corrosion. I can't say I've ever really found such a thing on tube pins. These are definitely scratched up. Look like they require any kind of thing. There's some chance straightening that out is going to help. Can you hear my cat hollering in the background very quietly? The weather's changing here. It's becoming cold. So not below freezing or anything like that, but cold enough that the cats are disturbed by it. They want to go outside, and when the door opens and the cold air comes in, there's a lot of squinting and disappointment. Well, you know, on the basis I have nothing else to do, I'll just these are all bent a little bit, especially that one there. Well, under a close-up camera, it looks like a big deal. You know, is that enough to I can't believe that would have any kind of effect here. So I'm going to pull it away from the camera so I can squeeze it with a pair of pliers. You know, it's not going to straighten out, I don't think. I mean, it's just a tiny amount of bend. I see nothing here that would make me think, oh, well, that's the problem. Nothing at all. Okay, let's take a look in the socket. Ooh, almost dropped the tube. Maybe that would help. There she comes. So these are going to be spring metal, and really the only kind of metal that has springiness that you typically run-of-the-mill metal is steel. Listen to that cat trying to get in here. Oh, she's broken in. It's making her presence known. Starting to see rust. What looked like rust, kind of a brownish color on some of them. I think these are called clamshell grips. So they try to provide not a sharp surface, but a flat curved surface. Yeah, a flat curved surface to make sort of not a biting contact with the pin. And maybe that's why these guys get into trouble. This kind of tube socket. There's others that are more or less like jaws, and they bite the tube. They don't have much contact surface. There's a lot of rust in there, isn't there? So steel rust, not conductive. Not like copper oxide, the brown stuff you see on copper. What looks like copper, a kind of brownish color, that stuff's conductive. But the rust is not metal, steel rust. These are probably galvanized or otherwise coated with something which appears to have given out. You need to get in there with a brush of some sort and let it have it. I gotta find something. Pipe cleaner. Looks big in the camera, but no, you know, these are tiny holes here, and you don't want to be sticking something in there that's gonna, you know, like the tube is like the best thing. The tube itself. The tube itself is the best thing. And I'm gonna plunge it a bunch more times. I mean, I just didn't give it enough abuse here. More abuse is what's required. The flushing thing. Now, if one of these has just basically, maybe it's the very ends of the prongs that are doing the cleaning. The imaginary cleaning. Hey, where'd the cat go? So if you have cats, I would ask you this question. Do your cats watch your feet a lot? My cats watch my feet. It's almost disturbing in a way. When I get up, they want to assess where I'm going. They watch the way my feet point. And if I stop walking, they just stare at my feet. I guess it's the big giveaway on, you know, what your intentions are, which direction you're going to go. And they seem to be able to even detect when I don't have the intent to go anywhere. Even though I might be trying to fool them by kind of dancing around a bit. They seem to be very smart about my feet. Or maybe it's just they're scared out of their wits I'm going to step on them. You're not going to step on them with your eyes or your head, so why look at that? It's the feet that are going to step on you. Maybe that's what it is. Well, Mr. Deoxit. So I'm an ex-corrosion technician. I've mentioned this on videos before. The kind of corrosion I dealt with was what would be called underground corrosion. In my case, it was lead power cables. Lead as in the metal lead. These are power cables the size of your wrist. 3 big conductors inside, insulated with paper. Yes, paper. Maybe carrying 8,000 volts between phases. So that's, and a lot of power. And the outside of the cable, in the earlier days, was just a lead sheath, more like a lead pipe. Of course, the lead is a little flexible, so you can bend the cable. If it were steel, you can't bend it, of course. So use lead. It's pretty good. You can bend it on the cable reel, bend it off. But bare lead does fairly well in underground situations where there's water, groundwater, leaky water pipe water, rainwater, filthy, dirty water. Generally, the lead builds up a patina and the action stops. Unlike steel, the rust is adherent to the lead. The steel, the rust, the volume of the rust is 7 times the steel it comes from. So it literally pushes itself off the steel and turns into that ugly schmozzle you see. But lots of other metals are corroding, but the corrosion product is tightly adherent to the metal, like that. So you see how this doesn't have the metal luster? It's a little bit shiny, it's kind of dirty, but it doesn't quite have the really reflective luster, more like the glass here has. If you buff this up enough to scrape off the coating here, you'll end up exposing metal. This may not be the best example, and it'll have that luster, the reflective quality, which I believe is actually the electron cloud on the surface of the metal. Whereas here with this very thin adherent corrosion, the electrons may be contained inside of it. Maybe that's why copper remains conductive even with a certain amount of corrosion on it. Steel's a bad actor in these radios. Steel, can't live with it, can't live without it. Well, let's give it another try. Maybe I have to let this stuff dry completely, but it looks to me like it takes a long time to dry completely. Not like WD-40 is fast, fairly fast. Yeah, WD-40 is my favorite. Simple stuff, very simple stuff. Okay, let's try the radio again. Plugged in. Grab the volume control. Here we go. Oop. So the fact that it's stopped working, again, it sounds like some kind of oscillation. There could be a powerful oscillation in the radio right now, which is driving the AVC to quiet the radio. And then it stops. Breaks. Yeah, breaks right there. You can have an oscillation that doesn't produce sound out of the speaker. And I'm pretty sure that's what's happening there. That's probably just an alignment issue of some sort. Okay, we'll put it up here where it operates. Sounds like a radio to me. Now, here we go. Finger upon the tube. Oh, we're getting there. That's pretty reliable. We have to get to a certain level of reliability, or there's no use trying to align this radio or do anything more with it. Well, not bad. I think we got there. I think it's worth working through the alignment process with this radio now. And did they by some chance write that here? Instructions. No, they did not. But happen to have the whole story here. Oh my gosh, I remember this. Very, very wordy explanation. So the fellow who wrote this really took time to explain things. Often you just get a little chart with some frequencies on it and not a lot of words. Here he's used lots of words. So I'm going to go read this stuff. Important. Never remove or replace tubes while power is on, or blown filaments will result. Yes. A lesson I learned the hard way quite a few years ago. And that's why I'm so scared to work on these kinds of radios. And I don't have many of these tubes in my stock, and I really don't want to blow a set and then stick another set in and blow that too. Yeah, that's right. So I'm going to read up on this. We're going to let this guy sit here for a while, not operating though. And I'm going to go see what's going on with my cats. Hey, where'd they go? Poor guys. So the person who wrote this took time to write something quite nice here. So I'm going to read the whole thing. I need to read it again. So IF alignment and RF alignment. We'll start, of course, with the IF alignment. IF transformers are to be aligned at 455 kilohertz. Well, let's get there. 455 kilohertz. To feed the signal into the set, place the output lead of the signal generator on or close to the loop antenna in the lid of the cabinet. Do not connect the ground lead of the generator to the chassis. Okay, so I can do that easy enough. I'm going to use this high-tech coil here. This is the output. I'm just going to leave it hanging like that. That should do the trick. If the IFs are badly off and the signal cannot be heard, and that's not going to happen, I don't think, connect the generator temporarily to the grid end of the antenna by means of the lug on the inside of the case. Here. The grid, and in brackets, hey, the grid lead goes to the side of the variable tuning condenser, so you can trace the wires and figure out which one to hook up to. Tune the IF transformers for maximum output by means of a small insulated screwdriver. Starting on the end nearest the S3 the 3S42. So that's this one they're referring to. If the set, now this is the important part here, if the set oscillates or hisses excessively, slightly detune one side of one or both of the IF transformers until the trouble disappears. If the set oscillates or hisses excessively, slightly detune, slightly is underlined, slightly detune one side of one or both IF transformers until the trouble disappears. Don't tune both sides. Well, I guess if you want to detune it, you need to move one side off. If you move the other side off, you could retune it to the wrong frequency. And we're talking about slightly with an underline. Okay, great. I think we're ready, except I don't have the non-metal tool here. Just this guy. Much of a blade. Let me give it a little test here and just see. Yeah. So the problem with using these very soft, flexible tools, as I've talked about a million times, is they act like springs. And so if the screw is sticky, when you turn it, you simply load tension into the plastic, and then it releases, and you end up with a screw that is either here or here or here or here. You can never get it in the middle, which is why I like to use metal screwdrivers. Often I'm compelled to use a metal screwdriver. So that's not going to do it. So I need something stiffer. Now this might be good. This has a little metal piece in it. It could also be because there's some voltage here. I have once or twice encountered it in radios. So we're starting with this one. I'm just going to, yeah, that'll move fine. This guy, he's sticky. This one's really stuck. I'm going to loosen it up a bit. Oh, I think it's cranked down hard. I think that's what that was. Okay, maybe that's a good reason why the set wasn't working. Okay, so we're putting out a frequency of 88,080, but I know what it was before my counter started doing that. Turn the radio down, put it on. Well, I don't hear it. Now let's just make sure we've got modulation going over here. 30% modulation, very low signal. Just trying to leak it into the antenna and leak it through the radio this way. Kind of. Maybe I'm going to give it more power. Still not hearing it. So what I'm going to do, I'm going to search for it a bit here. Just a little low. So first I'm going to try to peak it up on that frequency to get everything close. Start with this tight down screw. Getting quieter. Not a good sign there. Let's go on the other side. I thought this was loose. Oh my gosh, this is... Okay, bring out the metal screwdriver, my beautiful antique metal screwdriver. Turn the set off while I'm doing this because just in case there is that short circuit concern here. Oh my gosh, these are just rock solid here. Oh, just driven right down tight. Maybe somebody came along at some point and said, hey, these are loose. Tighten them up. How about these ones? That's pretty normal. They're also down tight. Not really tight, but snug. They're all snugged up. They're all snugged up. I think I'm just going to back them off a little bit here. you know, ideally they're somewhere in the middle of their range, not snug down tight. Okay, ready again. Let's go back on. Or nothing now. Okay, 455. Let's give it more power. Nothing. A little bit would be nice. That sound is not helping. Well, let's see what happens here. Maybe I'm wrong and these are all snug down because that's where they gotta go. We've got a pretty hefty signal. Loosely coupled. Ooh, that was nice. Let's hang on that. Something anyway coming through. Is it related to this? Yes. Not supposed to do that, radio. Picking up its IF frequency. Maybe that's what that oscillation was. It's kind of quiet spot here. Should really have the capacitor closed, I think. Wow. Uh-oh. Breaking into oscillation. Okay, let's go where it's not oscillating. Check for the frequency. What's the frequency, Kenneth? There's no frequency. Okay, mess this one up too. You might have to do these one at a time in the end. Is that just some wild coincidence? I just kind of randomly set these. So maybe I have them tuned. Well, if I have them tuned to the wrong frequency, we should be able to find it with that. Down with you, down with you. Even this is twisting. Down with you. That's what I want to hear right there. Let's check and see if we can hear it in more frequencies than that. We have something happening here. 386. 448. A little teeny bit there at 523. That's nope. We're right up into the actual AM band at that point. So what's happening here? Let's find this guy down low. The down low. Cranking it down hard, making that frequency come through. He's a bad actor. It could be the state of affairs with this radio was somebody screwed these down fairly tight just listening to the radio and discovered it made noise like I'm discovering with these screwed down tight. But at the same time, it's so far out of real alignment it can't pick up a station. Just noise. Whoops, wrong thing. Oh my gosh, it's this. That's what I'm tuning. Well, I'd love to kill this. I think if I can kill the local oscillator. Could do that. Say goodbye to the local oscillator here. That would get rid of that extraneous tuning stuff, I believe. To kill that. So I'm looking at the capacitor. Is it up on grommets? No, it's bolted right in. So we're going to put this on the chassis. This is just nothing more than a capacitor. Stick this on the... Well, let's tune it in. Hey, come on. Yeah, I'm on the wrong plates. Onto the stator. It'll get rid of that. Make this stay there. Go in there. And just stick it like that. And have it just sit there. That's a silly way to do it. I'm sure it's going to fall over. Nothing like a challenge. So no local oscillator. Full tilt on this guy. Not quite full tilt. Let's see, what do we got? Oh, it's lots of... This is actually full tilt signal coming out of it. I should take that clip lead off up there. Okay, let's find him. Where are you? The other thing too, which is to turn this turn this way up. I heard the set go into oscillation there. The little thwomp sound. There's nobody home here. It's kind of a random thing happening here. Very microphonic. It causes feedback. Oh, this is a very, very... It's a very, very... Guess there are better ways of doing that. Wow. It's not going well. Can't say I've ever had a radio that just you couldn't find the IF. Did I do something wrong here? Did I? It did say 455, didn't it? 455. 387. Stupid of me. What happened there? I think I had 445 for a while. I'm just not making the coffee strong enough these days, quite clearly. All quiet. So in a case where you can't get them lined up enough to get anything through, you have to do them one at a time. And what they're suggesting is you basically pound more signal into the antenna by hooking up more directly to it. Maybe I should consider that, because I'm getting nowhere here. Is there something else I'm not thinking of? What else would I not be thinking of? We need more signal. More signal. And if I use a bigger interface coil like this. Whoa, that's a good clip lead there. Good clip. Go on, stay on. No, that's not going to do it. Okay, it looked like it was happy enough to sit up here on its own anyway. There we go, that's plenty close. Pounding 455, the number, into the antenna. Okay, turn these down. Sounds exciting. Sounds less exciting. Freaking into oscillation there. A little whoomp. I don't know if you heard it. It's not supposed to sound like a radio. It's supposed to sound like a signal generator. What are you doing here, mister? Okay, we're going to screw them down a little tight where they were. There's nothing coming through here. I don't get it. Something more seriously wrong with this radio. Maybe that's the conclusion. Okay, we're going to do the direct connect thing. So one wire that goes to the capacitor is the one we want to hook up to. Let me shut. No, I'll leave it on for now. It's this one here. It's this one. It's the front one. So we'll get a capacitor in here for a little bit of added protection. My signal generator is already protected with a capacitor inside this little box that you can see sitting here. But I'm putting another one in. Okay, I'm going to reduce the output way down. Now in doing this, I'm just supposed to hook up one wire. Just the one wire. If the IFs are badly off, they seem to be badly off, and signal cannot be heard, connect generator temporarily to grid end of antenna by means of lug. Grid lead goes to the tuning condenser. So it doesn't really say don't hook up the ground, but that's what I'm going to do. I'm not going to hook up the ground. I'm going to bypass that resistor there. Ooh, she's a hummer. She's a humming now. So, hopefully that's not bad on the signal generator. I'm a little worried about that. If you put the ground on, why not put the ground on? Risk of, it's a hot chassis radio. We've got things connected to the chassis. There's a chassis symbol here, chassis symbol here. There's a ground symbol here. What are they doing? The chassis symbol at the antenna. I think we can put a ground on the chassis. I think we can ground this guy here. Okay, famous last words. Ground that puppy. No sparks. Get rid of some of the hum. Okay. Still don't hear it. I'm going to pound up the signal strength here. Hunt for it a bit. More volume. More volume there. Ah. I've got something. Cannot be related to the tuner. No, it is not. That's the IF. Okay, we're in business. Excuse me. We just got to get it out to 455. So let's go up a bit. Still hear it very faintly, and boost it up. Boost it up. Boost it. Oh, cranking this down tight and it's boosting. Ooh, that's not good. Okay, let's do this other one. So that's why they're cranked down tight. Something not right about them. Maybe I'm the guy who cranked them down tight. Oh my gosh, barely get that. Okay. I would think, based on the signal level coming out of that signal generator, this should just be screaming. Okay, there's a little screaming. Still hear it. Wow. Tell me, what's going on with this one? Let's check this guy again. It's kind of at the bottom of the range of the screw, but you can hear the peak going by. Let's go up. Less capacitance. Did the trick. Maybe here too? No. This guy wants more. 450. We're getting there. How come he wants more now? Tool just isn't going to do it. This is too small a screwdriver, no power in the handle. Okay, Mr. Metal, you're going in there. Why don't we just do a little safety thing here? These are very sensitive tubes. I'm just worried one little boob up. So that's just reading voltage there. Is there any volt? I mean, there shouldn't be, but let's just see. Yes, there is. Nothing. Nothing there. Okay. I'm reassured. Now, if you bump the side of the can, it might cause a tuning variation. There we go. Let's see what's happening. Nothing. Okay, I can drive this down a lot harder now. This one too. Wow. Okay. Let's go down. Trying to keep the input signal as low as I can. How about these guys? Sounding more like a radio every time. That's a very sharp one. Wow, so this one's a little bit off. It's silent. Well, we're pretty close. Looks like give it all it's got. Oh my gosh, it's just where are we at here? 450. I don't think we're going to get any further. Okay. Let's play the radio now and see what happens. I'm going to cut this back, take this off here. Hot diggity dog. She's a loud one now. Anybody home? Oh, that's close. Take this away. Try to steer the antenna a bit. I think nothing's showing up easily. Left this ground on. Got rid of the hum. Oh! I hear a station. Yep. Okay, I'm going to help this radio out. Take this loop antenna here. So I can tune this to the same frequency that this is picking up. Looks like probably 590. And this thing will boost the signal. I don't have to connect it. Just having it close should boost the signal. See? Wow. That's odd. It's bucking the signal. Maybe it's got to be like a so. like so. Maybe here. Too far away. Strange. I can't say I've ever had it null. Everything's awkward. This is not the best place to be trying to pick up AM radio here. Is that enough to carry on? Let's find out what frequency we're tuned to. Just throw this here. Take this off. We're somewhere around 55, 600. .590. Okay, so 590 is the strongest AM station. Let me put this up. Okay, some more alignment activities here. RF alignment. Loosen locking nut on oscillator adjusting screw. The oscillator adjusting screw is down here. I do remember playing around with this. I do remember this. And then the tubes were popping in and out. I couldn't get anywhere. That's what I remember. With tuning condenser closed and signal generator set to 540, adjust oscillator screw for maximum output. With capacitor closed. Here we are. 540. Very hard to hear. Just try to boost this up a bit. Boosting. Oh yeah. There we go. Turn the volume up. Input down. Okay, and then what? And then what? Adjust oscillator screw for maximum output. Okay. I'm just doing this by ear. Where's that great little screwdriver of mine? Okay, what is this? Oh, I remember now, this was broken. That would be that. Next, with the tuning condenser open all the way and the generator set to 1650, adjust oscillator trimmer on side of front tuning section for maximum output. Repeat the two things. Let's read what he says. Repeat the 540 kilocycle adjustment, leaving the oscillator trimmer unchanged. And so on until neither one requires appreciable readjustment as the dial is turned from one end to the other. Now set the generator above 1400 and adjust the antenna trimmer on the side for maximum output. Okay, so we're going to do the 5. So we're doing the 540. Now we're going up to 1650. Going up. Working all the way. No oscillations in the set now. 1650. Okay. Oscillator adjustment is inaccessible here. I gotta swing this a little bit. Okay, oscillator adjustment. I like my wooden screwdriver. What did I do with it? Son of a gun. There it is, way back here. How did it get way back here? No effect. Okay, we want to go to 1650. Take this up another notch here. Make it louder. Oh, I jumped right past it. Okay, 1650. Ooh, that's sounding nicer now, isn't it? That's 1650. Once again, I'm just doing this by ear. Oh, it's a hair trigger on this radio. Okay. Go down to 540, right? Looks pretty good to me. There's two things in there. No, my imagination. That's pretty good. I think that's it. I don't see that there's any more need to stretch it around. And so on until neither one requires appreciable readjustment as the dial is turned. Now set the generator to above 1400. Adjust antenna trimmer on side of gang for maximum output. So we're going to go to 1400. Okay, and a little more oomph. Find it. 1400's up here. Pick a quiet spot here. Ooh, it's way off. Way off. 1400, 1350. I should check the actual frequency down here around 640. Let me do the antenna thing first. Do it this way. Okay. Ooh. Uh-oh. Quickly. Deoxit. That's kind of interesting. You know, maybe some parts kind of relaxed because of the oil. Definitely had problems with shorting in this one. 1400. Where'd you go, baby? Where'd you go? Oh, I killed the radio with that stuff. No, don't believe that. Oh, where'd you go? Not a lot of signal. Lots now. Way up here. It's like 1300 or something. Yeah. Okay, so at 1400, we'll get 1300 because I sprayed that guy. Overloading. How did he get that far out of there? This shouldn't retune the radio what I'm doing here. This should just... It wants to go in where it's shorted. Just pull the screw right out. So probably the capacitor is probably just shorting. I think it might be shorting against the little screw. Is it loose here? It's soldered in solid here. Can't imagine it's moved. So just that this has got... So this is a fiber thing. You wouldn't want something soft in there. Really keeping the screw from touching, except just the way it is. Just the way it is. Let's see if I can use this guy here. Yeah, this is just a 5-minute job doing this kind of. What exactly is happening here? Looks like it's out on the far edge. So there's a piece of probably mica in here. And maybe it's not sticking out far enough. Quickly, jump to the close-up camera. A little better lighting on this. Okay, that's just the antenna falling off the radio. I got too many things in my hands here. Okay, back up there. There we go. If we look at this one, we can see the plastic. Is it missing? No, it's in there. Did it get spun around? Let's see, the left side comes right over, pretty close to the center. Same as that one. Did the far end break off? I don't see the end sticking out. Appears to be missing. So they clamp it down hard enough, this far end of the copper part shorts. I think if you look right above the screw, you can see a break. broken mica. Oh, I've got some mica. I'm going to go get the mica and show you the mica. My wife and I go out for drives regularly. We live in a really interesting area geologically. And we stop and pick up nice looking rocks like this. Lovely piece of granite. This is actually called pegmatite. See the large crystals of it in here? And look at that. That's mica. That black stuff is mica. Can you tell it's in sheets along here? So this is not the kind of mica that's used in electronic components. This one isn't suitable. This is a black mica. Dorite? I don't think it's called dorite, but it has a name. Just there it is, coming right out of the rock. It's a very nice luster to it here. Kind of a goldy colored luster. It doesn't look so good on the camera, but there we are. That's what mica looks like when you dig it out of the ground. Yeah, very interesting area to live in. Geologically, as I've been discovering, as I've been teaching myself or learning about geology and how it applies to this area. So what about that? What could I do with that? You can pull the piece of mica out of it and look at it. Pretty sure. Let's try that. Let's try that. I took the screw out. The world did not end. Let's take it out again. And take a good look at it. Okay. Let's not release the screw and the washer. How to get that out of there. So I think it would pull right out now. How do you break a mica sheet? Doing stuff like this. I think I gotta loosen off the copper here a little bit. Maybe we can, you know what, it really is broken. I can see it with my own eyes. So we need some mica-like material. Mica-like material. I certainly don't have spare sheets of mica around. I really just want something to kind of stop it from shorting there. You want it to be very, very thin so you can crank it down quite a ways. So just an ordinary piece of plastic's not going to do it, I don't think. I'll think about this a little bit and then fix that. Okay, so I'm going to try just a piece of plastic. Nothing special about it at all. This is really full of holes. That's special. Okay, here's a whole area. It's got no holes. So that rock I just showed you would be somewhere in the range of 1 to 1.5 billion years old. Found that there's a whole world of that rock just north of where I live. And the Canadian Shield stretches on for forever, basically. There's no reason to make this trimmed up really nice. Just don't want it crazy excess. So when I go outside and I look around at the countryside and where I live, what I'm seeing is about 10,000 years old. It's the dirt, the soil, all that kind of stuff. Where I live here, if you were to dig down a ways, you come across bedrock that's about 450 million years old. Then you got to go down quite a bit further to get to that kind of rock. It's buried under it. But if you go a little ways north, the 450 million year old layer ends. By the way, everything above 450 million years, rock-wise, was gone. It was removed by the glaciers. The glaciers were able to scrape down through all those different ages, and I'm going to try to fit the screw in and then slide that in. But when they got to the 458 million year old limestone layer, they couldn't beat it. They could not. It doesn't break up and get carried away. Glaciers generally break up rock and carry it away. So if the rock is already fractured and stuff and glaciers eat it up, it's gone. But if you have really solid rock, like granite, like well-formed granite, or limestone is very hard, the ice doesn't win. The rock wins. Especially if you've got, in the case of limestone, very wonderfully formed limestone, very consistent limestone. Maybe even with some dolomite, which has to do, I think, with potassium in the rock. They can stand up to it. I posted a video last night. You may have watched it. Short video of a little trip my wife and I went on, just 20-30 minutes from here. So a two-part video. First part is showing a marsh. It's called the Tiny Marsh because it's in a county called Tiny. It's not that it's a tiny marsh, it's a big marsh. That marsh is sitting on top of limestone. Now limestone is so continuous it doesn't drain, which is why you can have a marsh on top. That's going to work. Down just a wee bit. In that video, there's a scene where my camera is aimed at a bulb of rock sticking out of the ground. There's a guy fishing at the base of it. Now that bulb of rock is what's called a pluton, and it's granite. Pluton, if you think of a lava lamp, and inside the lava lamp you see the wax coming up as a bubble. So that granite rock, when it's molten, comes upwards like a bubble. It must have gotten through the much younger layer of limestone, or the limestone formed around it. That's probably what happened. That pluton came up. We're talking a mile under the ground. And along comes the glaciers, sweep everything away, down to reveal this granite bulge. All alone out in the middle of this limestone plain. It's very unusual. Okay, let's see if this works. Because I could talk about the geology thing all day, and just like this, I only half know it. So take everything I say with a grain of salt. Volume down, power on. And now, so we want to tune in the signal there. Hello. And radically change the frequency of that trimmer. The trimmer's out a little ways. Well, it's no longer shorting. The set's no longer receiving. Give it the works. Oh, I know why. The antenna fell down. That's why. There it is. Okay, setting the dial to 1400. Overload. Okay. Turn up the antenna. Nice. Right there. Now, how bad is this dial? So if we come over here and we set this on, let's say 700 on the dot for 700. What do we actually get? Oh, 700. Whoops, whoops, looking at my shoulder there. 700. Oh, diggity dog. Okay, let's take this away. Take this away. Okay, radio. Show us your stuff. Got much stuff. There's stuff there, but not much. Okay, can you help them out? Definitely the sports channel. We're now going to fiddle it with the IF just a wee bit. Especially this one here. Right on the money. Can't do much about these.
Well, essentially, it was called State of America's Pastime Act. It essentially prevented minor league players from collecting overtime or claiming wages. The whole thing is just rates a year. But it's interesting too because when Major League Baseball took over the operations of the minor leagues, which it started to do last year, and scaled down the minor leagues, one of the things that kind of brought on itself is, okay, if you guys are running the minor leagues, now you're responsible.
So what's happening there with this antenna? As I tune it in, it kind of sounds like the radio is getting weaker. I think what's happening is the signal's getting stronger, and the ADC is turning down the sensitivity of the radio. So the noise kind of goes away. Makes it sound like the radio's getting weaker. There it is. That's about as good as it's going to get, I think. Again, if this were outdoors, it'd make a big difference. Now, what to do about the asbestos? So I see it's nailed in, which means it's going to get ripped up as it comes out. I would not do anything with this kind of asbestos here in my shop. I can see it's already frying out here. There's bits and pieces missing over here. There's probably all kinds of dust in here that is actually asbestos particles. Probably at my age I don't need to worry about that kind of stuff. But nevertheless, I don't want a buildup of asbestos floating around in my shop here. So my choice is put the thing back together and don't worry about it. That's not a bad option, really. And the other one is take it out. I'd have to take this outside of my house, right out in my driveway somewhere. And if it's a windy day, I can stand up wind. If it's not, I've got breathing stuff I can wear. Got stuff like this here to wear. What am I going to do with this one? I think I'm going to leave it in. I'm going to leave it in. Leave well enough alone. So that's it for this radio, finally. Okay, video number 11. There it is. All done. So thanks a lot for watching, and I think the next thing that's coming in here is the FM radio I was struggling with a couple or 3 weeks ago. We'll just continue the struggle. Thanks a lot for watching.